Hello students, welcome to Math 2414 Calculus 2. As the name suggests, this course is a continuation from Calculus 1. Therefore, we're going to begin with a review from Calculus 1. Everything here in Lesson 1A is review. First, the definite integral. In Calculus 1, we use this graphical explanation to explain the definite integral. Basically, it is a signed area. Above the x-axis, positive, below the x-axis, negative, and then add them up. Roughly speaking, in this case, it is blue area minus red area because red part has negative, blue part has positive. So if you add them up, you get the signed area, which is a definite integral. Now, the properties of definite integrals can be classified like this. One, the property is intrinsic to the definite integral, and then the area property, which can be explained like this. So the definite integral from a to a f of x dx is always 0, no matter what the integrand is. Well, here's a graphical explanation. Starting and ending at the same value. So basically we have a line segment, and the area of this line segment, of course, is 0. Next, the integral from a to b plus the integral from b to c is the integral from a to c total. Here you go, from a to c, that's the total signed area, and blue part is from a to b, and the red part is b to c. And then the total is from here all the way over there. So the graph explains everything. And then put these two together, and then you can prove that integral from b to a f of x dx is the same as negative of integral a to b f of x dx. Basically, we're going backward, then we get negative. Basically, if you add them up, then you get ab, ba, so a to a. But that's 0, as we proved here. Graphically, I mean. And there goes 3 basic properties of definite integrals. And then the other basic properties are linear property. Basically, we are talking about a signed area. So if we stretch it in y direction by k, so the area is increased by k-fold. And then if you add up the integral, that means adding up the area. Again, the same deal. A quantity that is not that important, but graphically explained like this is the average. Average value is this y-coordinate value here, which is defined like this. So basically, the area of this rectangle is the same as the signed area. Let's see, we have some example problems here, all right. And integral from 0 to 3 f of x dx. Okay. Each I, or each grid is 1 unit. So 0 to 3, so 0 to 3 up to here. Let's see, let's go to graphics mode. So we're talking about this portion. And then everything is below the x-axis, so the integral will be negative. And now let's see, we have 3 rectangles or 3 squares completely. So negative 3, these two almost completely. So negative 5, half, a little bit more, maybe about negative 6, or a little bit less maybe. That's my estimation, about negative 6. Yeah, kind of like that. It's just rough estimation. How about 3 to 6? So 3, 4, 5, 6. So you see negative part and positive part you'll have to consider separately, and then add those up. And then here you can approximate more or less as a triangle. Again, more or less as triangle. And if you add up, I'm getting about 4.0, roughly speaking. And the real value is about 4.23 something. Okay, that's acceptable for an estimation. So what did he talk about? The definite integral is signed area, and we did some estimation associated to it.